under the track Data Science and Analytics. And in this session, the paper ID is 84, 85, 120, 188, 408, and 473 will be presented. And the time for presentation is 10 minutes for each presenter and 2-3 minutes for question answers. And please stick with your time. So I request now to paper ID 84, please share your screen and start your presentation.
Is my screen visible?
Yes, it is visible. You can turn on slideshow. You can just press F5.
So a very good afternoon to everyone. I, Manish Sharma, is here to present a research paper on behalf of my fellow authors. Our paper topic is a comparative study of loss function for imbalanced data set of online reviews. And our paper ID is 84. So starting with the presentation, let's have a quick background of what we have done in our research paper. Now, the loss function helps in evaluating the performance of a model trained on specific parameters of the dataset, while loss function also serves as a penalty for a bad prediction to improve the prediction with its testing values. While in case of prediction on an imbalanced dataset, the loss function must be modified so that the weights of loss that occur due to misclassification may be unchanged. This focal loss function will be compared with normal cross entropy loss function, which is widely used in the evaluation. Now, final comparison between the two loss functions, which will help determine whether the change of loss function can create how much difference in model performance. This paper also implements on the Google BERT model for sentiment analysis and loss function evaluation. After selecting the training model, the loss functions was to be evaluated was studied, namely the cross entropy and the focal loss. After testing the model with various loss functions, the F1 score was calculated with Google Play Reviews dataset, and the best out of the loss function which could be used for sentiment analysis of an imbalanced dataset will be concluded. Now coming to the literature survey, we have gone through various research paper. Now for the comparison of loss function, first need was an imbalanced dataset. The dataset has to be prepared to compare the cross entropy as well as the focal loss function. For further reduction of errors due to misclassification of imbalance of dataset, they have used the focal loss function. Now coming to the finalization of the dataset, the next topic of discussion is the model to be trained on this dataset. The research started with trivial machine learning models like KNN and SVM. The result of this paper shows that the SVM model, which is support vector machine, is better than the KNN model. And now coming to the models, the LSTM model can efficiently deal with exploding and vanishing gradient problem. However, since the LSTM model has to be trained for classification, there are no pre-trained LSTM models. So now coming to the BERT model, which is based on the transformers, which are mainly used for end-to-end speech translation by creating embeddings of sentence in one language and then using the same embeddings by the decoder to change them in a different language. So the comparison of LSTM and BERT for small corpus, it was seen that the BERT model performed with better accuracy in case of small training dataset, while in case of LSTM, which performed better when the training dataset was increased up to 80%. At last, the BERT model was finalized for the models training. Now coming to the dataset used in this paper, the dataset was the basically Google Play reviews, in which the review ratings were ranged from 1 to 5, and they were categorized as ratings as 1 to 2 as negative class, and the rating 3 as neutral class, and the reviews which were greater than 4 rating were classified as the positive class. So the data set was a balanced one. However, the imbalance was created to compare the two loss functions for imbalance on the data set. The number of neutral reviews decreased up to 20% for one iteration to form one data set, while on the other hand, the balanced data set in the balanced data set, the neutral reviews were decreased up to 40% for the next iteration to create a second set of imbalanced data set. As you can see, the data percentage for different reviews in all different data sets in the table 1. Now coming to the two loss functions which was used in this paper, the cross entropy and the focal loss function. The cross entropy is one of the most important and most often used loss function. As we can see from the formula, the cross entropy function is summation of binary indicator and logarithmic value of predicted probability. However, in our data set, we have more than 2 classes. Thus, instead of using binary form, we use the second formula, which is the summation of binary indicator and logarithmic of predicted value for each classes. Now coming to the focal loss functions, the modification of cross entropy in which we have 1 minus pt to the power gamma, where gamma is modulation factor, which helps to decrease the penalties to well-classified examples and increase penalties due to misclassified data. As from the figure 2, we can see that the focal loss does not accommodate penalties due to well-classified data, which is sometimes good in case of highly imbalanced data. However, it can decrease the accuracy in case of moderately imbalanced data. This modification of loss function does not always lead to better accuracy. Let's find out from our results. Now coming to the model used here, the BERT model is a transformer-based machine learning technique, and here transformer is an architecture for transforming one sequence into another one with the help of encoder and decoder. In case the BERT is a cascaded model of the encoder part of transformer. Now coming to a question that why BERT and not any other neural network? So basically, bidirectional LSTM is trained from both left to right to predict the next word and from right to left to predict the previous word. But in case of BERT, the model is made to learn from words in all positions, meaning the entire sentence. Now coming to the second point, that is high parallelizability, in which with the help of multi-head attention mechanism, the BERT model is able to process all tokens at once, while in case of other deep neural networks like RNN or CNN, the token processing takes place sequentially. Now coming to since the BERT model process the token all at a time, the time accounting for the training of model decreases a lot, thus making it faster than other deep neural networks. So basically, we use BERT over any other neural network. Now coming to the methodology, that is the model architecture used here. After the data set was formed, the data pre-processing was done, and with the methods like class normalization, in which reviews were normalized to positive, neutral, and negative classes, and in data cleaning, in which all characters like hashtag and other non-alphabet characters were removed, and then the tokenization was done, in which a sentence is broken into each word. Now, after that, step word removal was done, in which the all irrelevant tokens like of, and, or were removed. And then the lemmatization was done, in which complex words were changed to its root form. After that, this pre-processed data was fed into the BERT model, and then the separate classification with focal loss and cross entropy loss functions were performed. And then final comparison and formation of performance metrics was done. Now, coming to the result part, the accuracy derived from training the dataset on BERT is between 0.75 to 0.78 for focal loss, while on the other hand, for cross entropy loss, the accuracy is between 0.80 to 0.90. In case of balanced dataset, the accuracy for cross entropy loss is more than that in case of focal loss. However, the focal loss has been a modified version of cross entropy loss. Still, the cross entropy performs better in case of balanced dataset. While in case of neutral classes, which we have decreased by 20% to create a little imbalance, the cross entropy has performed better than the focal loss. And in neutral classes, in which we have decreased by 40% to create more imbalance, the cross entropy also performed better in this case also than the focal loss. So in case of a slightly imbalanced data, the cross entropy always outperforms the focal loss, but also the focal loss is more focused on solving the imbalance problem in binary classifications problems only. As we can see in table 2, the performance metrics for both focal loss and cross entropy loss for a balanced data set is given. And here are the two tables for the performance metrics also for both focal loss and cross entropy loss for 20% and 40% fewer neutral classes for the dataset. Now coming to the conclusion, The loss function that showed better results is the cross entropy loss function over the focal loss function. The focal loss doesn't differentiate on multi-class as cross entropy loss is able to classify. Although the focal loss is a modification of cross entropy loss function, it is able to outperform only when the imbalance is high. In slight imbalance data, the focal loss function ignores many loss values due to modulating factor. While in future, more experiments will be conducted on different data sets to make a conclusion that a particular loss function performs well with a particular model. And also model can be further upgraded by comparing other loss functions for imbalanced data's most reliable loss functions. Lastly, the upgradation on focal loss has to be done mathematically so that the loss function can perform well even in a multi-class dataset and slight imbalanced dataset. Here are some the references used in the paper. And thank you.
Any questions from session chairs?
I had a very small question. Usually in transformer model, which I was trying to implement, I was facing issue of accuracy problems with lesser data. Did you face any such sort of problem in this? If yes, how did you tackle it?
I think in case of BERT, which is basically a transformer, which is based on the transformer model, the like the data set which we created was manually. Like we took the reviews separately, like the ratings 1 to 2 separately, and the ratings 3 separately, and ratings above 4 separately. And coming to the part of the accuracy, like we did face some accuracy issues in earlier stages, but using the loss functions on the more imbalanced data, like we created imbalance in the data set. We upgraded the accuracy much better using the loss functions.
How much data did you have in terms of quantity wise? How did you store your files?
Like for ratings 1 to 2, we have more than 5,000 reviews, and for similarly for balanced data, at earlier stage the balanced data set was balanced in case of ratings 1 2 and rating 3 and rating 4 5, each 5,000, around 5 to 6,000, and then we created imbalance in the neutral set for 20% and up to decreasing 20% and 40%. Using the Google, we actually scrapped the data set from Google Play by using the Google Play scrapper library using the Node.js.
Okay, fine. Thank you.
Thank you.
Any
Yeah,
other?
I have one quick question. Okay, about the methodology. So as mentioned, okay, when you compare BERT with other neural networks, okay, you mentioned that okay is faster. So is there any prior study, okay, justify okay how fast, okay, in terms of percentage when compared with other models? Thank you.
So basically we compared BERT and the bidirectional LSTM model and in that case we figured out that the BERT model was way better than the bi-LSTM in this case. The LSTM model was highly overfit, and also it doing the sentiment analysis, the LSTM model performs one sequence at a time, while the BERT performed like using tokens all at a time. So yeah, that was the case.
Okay, thank you.
Thank you.
Okay, we'll move on to the next presentation, which is paper ID 85, Mr. Amarjit Yadav.
Thank you.
Yes. Yes, sir. Let me share my screen.
Amarjit Yadav, your screen is not visible. Please share the screen.
Sir, now visible, sir?
Yes, it is visible. Now you can turn on slideshow.
Yes, sir. Now it's fine, sir.
Yes, you can start.
Yeah, thank you, sir. Good afternoon, sir. Good afternoon, ma'am. Good afternoon, everyone. Myself, Amarjit Yadav. Today I'm here to give the presentation on the topic of a hybrid approach for missing data imputation in gene expression dataset using extractive regression and genetic algorithm. So these are the table of content that today we are going to refer backgrounds to the survey. So first of all, going on to background. So first of all, know about what is the missing value. So missing value is also known as missing data. Is that some of the observation in data set are blank, due to some manual data entry, practitioner failure and device errors failure and operator failures. So an inaccurate measurement, just because of that, there's in data set missing value occurs, and in data set missing value could be represented as question mark, NA, blank, sometimes negative value also there. And absence of data reduces statistical powers, and the lost data can cause bias in estimation of parameters. Because of the result, that result will be biased and decrease efficiency. And missing data reduce the demonstrations of the samples. These are the literature survey, like GMC impute, Gaussian mixture impute is more effective because it can better utilize global association knowledge. But there is some limitation, but this technique has an issue with slower fitting, because in global fitting based on a global correlation data and missing value is acquired from entire data matrix. And HPMI hybrid prediction model multiple imputation in terms of precision, selectivity, and sensitivity. HPMI outperforms other methods, Bell, and in case of imbalance classification in multi-class dataset creates a problem for HPMI methods. And next one, the genetic algorithm plus support vector regression. This model needs less computational time, and SBR clustering method gives a more practical outcome. But limitation is that like this imputation technique suffers from a local minimization problems, and this method fails for some outlier data. Outlier data means like there's whatever the expected value will be too different from the range of the given data set value. Fuzzy C means method provides appropriate value computation for distorted data, and it also helps with the reductions of meaningless data and clustering efficiency in noisy environments. But limitation is that it becomes hard to extract and regulate prior knowledge. It also computational time, it takes too much. These are problem descriptions. Global approaches such as SVD impute ignore the hidden local structures of the data, and local approaches such as LLS impute performs better for small sample size, but it gives unsatisfactory outcomes on big data sets. And most of knowledge assisted technique, for example, FCM takes extremely long computation time, because in knowledge assisted technique we have to know about the domain knowledge. So that's why it takes a long computational times. And hybrid approach combining support vector regression genetic algorithm fail to detect outliers due to local optimizations of model. And deep learning techniques have high computational times. And these are the methodology that we are proposed in our paper. In this research, we propose to utilize a hybrid approach over K-means clustering combining genetic algorithm and extra T-regressor ensemble method to estimate missing data in prepared data set. So in my case, data set or the data we use, I am in MISP-14 data set, in which there is after pre-processing like 550 rows and 78 columns, and after feature reduction 550 rows and 20 columns. So first of all, data set reduced to implement the modern data set missing value are created artificially, and then the data set missing value is divided into complete data set and incomplete data set. And in incomplete data set, those rows are considered in which none of the attribute contain any missing value. And in incomplete data set contain rows with attribute with one or more missing value. So, and model is like extractive regressor. So first of all, the extractive regression K-means model are trained on the complete row data set to predict output. And then k-means is used to evaluate the missing data for the data set with incomplete rows. And k-means outcome is compared with the output vector received from the extractive regression. And optimized value for C and M, basically cluster and membership value between the extractive regression and k-means output. So after find out the output from extractive regressor O1 and income after testing on incomplete data set with k-means O2, and after that we are find out to optimize the error. So genetic algorithm is basically used for optimization because in genetic algorithm simulate the process of natural selection, which means those specified we can adapt to change in their environment are able to survive, reproduce and go to next generation. It basically focus on optimization of solution. There are some steps like initial population, calculate fitness, selections, crossover, mutation, something like this. So after that, the process, the main objective is to reduce the error function and static regression and prediction from the k-means model. Process continue until error is above the threshold value, and finally missing data are estimated using k-means with optimized parameters. Here the result and discussions. So efficiency of the missing data estimation model is evaluated using the mean absolute error, root mean squared errors, and relative accuracy on the different missing value ratio like 1%, 5%, 10%, 50%, and also relative compare with FCM support vector regression model and K-pod algorithm. And we'll find out like median RMSC and MAE value for proposed model is 0.01466 and 0.10105 respectively. These are the graph that we here box plot for relative accuracy in 3 methods for 1 to 15% missing ratio, and figure 2 is relative accuracy comparison of different technique for 1 to 50% missing ratio in the data set. Box plot is basically used for visual summary of the data, enabling researcher to quickly identify the mean value and dispersion of data set and sign of the skewness. And here blue line is indicated for our proposed model K-extra genetic algorithm, and red line is for baseline method FCM support vector genetic algorithm, and K-pod algorithm green line is indicated. And here x-axis is represented for the different missing ratio in the data set like 2%, 4%, 6% from 1 to 15%. Same things for here relative accuracy, find out the for 1 to 50% missing ratio. And these are the conclusion. The proposed model was applied to mice protein expression data set, which gave better performance than other baseline algorithm like K-pod and FCM SVRGA. And in proposed model, complete data set rows were clustered based on similarity, and each data point is assigned a membership function for each cluster. Sorry. Hence, this method yields more practical results. And the experimental result clearly states the proposed model yields better accuracy with 10% tolerance and low RMSC and MAE error than fuzzy C-means support vector genetic algorithm and K-pod algorithm. Limitation of the model proposed has indicated a need for a fast algorithm. Hence, the main focus area of the future would be reduction of the computational time for the proposed algorithm. These are the references that we are used. Thank you. Any question?
Any questions from session chairs?
Can you please show the result slide once again?
Yes, I'm sure. Yes, ma'am.
The second method shows a dip in the relative accuracy. Is there any particular reason for that particular point? Why it has come so?
No, ma'am. Basically, it's depend on the data set. Basically, I want tested on same data set for different. Different method like genetic algorithm, same as genetic K-pod algorithm. So when we are at initially, they are give same output. But when we are creating increase our missing ratio in data set, then it's like differ from that one.
Okay, fine. Thank you.
Thank you.
Any other questions? Okay, we'll move on to the next presentation. Paper ID 120, Mr. Brinda Senthil Kumar.
Yes.
Thank you, sir. Thank you, ma'am. Thank you, ma'am.
Is my screen visible?
Yes, it is visible.
So can you please turn on the slideshow?
Yeah. Good
Yes, you
afternoon,
can start.
everyone. Yeah. Good afternoon, everyone. I'm Brinda Senthil Kumar. Today, we are going to present our paper, Precise Stratification of Gastritis-Associated Risk Factors by Handling Outliers with Feature Selection and Multi-Layer Perceptron Model. Our paper ID is 120. I'm a scholar from Department of Computer Engineering, Mizoram University. The next few slides talks about background, objectives, methods, result in discussion, and conclusion. We know outliers are unusual data points which misinterpret data analysis and inference. Interquartile range method is very efficient to detect outliers. Namaco has utilized the interquartile range method to detect outliers and upsample the data, training data, so that they can have a balance during the training the model. And optimized isolation forest is very effective in detecting the outliers, so that the feature selection and locating the split point is able to precisely convert the model faster. And in RNA-seq data, they have applied robust principal component analysis to efficiently detect the outliers. We know those unsupervised machine learning algorithms are very efficient in detecting the outliers. Similar to this, K-means clustering has been applied on a central nervous system disease database, which has gained the accuracy of 10% than the multivariate outlier detection model. Sequential minimal optimization bagging techniques, based bagging technique has produced an accuracy of 82.6%, which can classify between the presence and absence of H. pylori from signs, merely from signs and symptoms, and vital signs from the children below 18 years. This work is done under WICA. The objective of this paper is to develop a model for sequential selection of methods or protocol to handle outliers and remove irrelevant features from this gastritis data, and to build a well-defined machine learning model which can accurately classify between the presence and absence of H. pylori associated gastritis. Why we have this work? Because H. pylori associated gastritis is the preliminary cause before we get gastric cancer. Mizoram has a high incidence of cancer among other Indian states. So even several papers have been told, like when the H. pylori, when they are positive for H. pylori associated gastritis, when they change their diet and lifestyle factors, even there are chances of avoiding gastric cancer. So in excuse me, 1 minute, please. I'm sorry. There are around 863 instances with 21 features. All these features are collected using a well-structured questionnaires. The features are listed here. We have taken the key features like smoking and smokeless tobacco use. Then Tuibur is a aqueous tobacco extract, which is predominantly used by people in Mizoram. Consumption of non-veg, raw, uncooked food. Saum is a fermented pork fat, and intake of salt, and source of water. Like whether it's been a treated water from municipality, or it's been used by the stagnant water or lake water. Sanitation, whether they use publicly available sanitation thing, or they have their own sanitation facility at home. So data box plot of the data distribution. So we have all the set of features here. A few features where Supari beetle we don't have because they are in discrete in nature. And then which the features which doesn't have viscous, the lower quartile range is in alcohol. The lower quartile range is equal to the minimum, and even for smoker we can see the lower quartile range is equal to minimum. So we didn't have viscous, and the higher quartile, upper quartile range is equal to maximum. So we didn't have the viscous in certain features. So as we have only 863 records, instances. So we want to see whether our data set will suffer from underfitting. So we have selected around 7 machine learning models. We have generated the learning curves. So from that we have selected a few models out of it. So from that, we can see the naive bias model, where the training score and validation score can convert. The error gap converges when the sample number increases. So we have selected naive bias, logistic regression, adaptive gradient boost, multi-layer perceptron, Bayesian trees. Whereas when we have applied on support vector machine and random forest, the error gap is very high. So we didn't use this these models to develop machine learning models. So workflow of our data preparation and data modeling. Raw data is subjected to outlier removal by interquartile method. Then supervised machine learning algorithm is applied on it, and we have calculated the risk stratification accuracy. Similarly, the raw data set is subjected to outlier removal by isolation forest. In isolation forest, we have given a contamination score of 0.1, and we have removed the outliers detected by isolation forest, and we have developed models using the removed sets. Then we applied a machine learning model, and we found the stratification accuracy. Similarly, we did for one-class support vector machine. One-class support vector machine, we know that it is an efficient unsupervised machine learning algorithm, which treats the whole data set as a single class, which doesn't rely on the target, and it learns a decision boundary from the data, and the points which is outside the boundary is detected as a outlier. For this, we have set the new to be 0.02. Then all these, after removing all the outliers, all these been machine learning or decision tree support, multi-layer perceptron, logistic regression, and naive bias, adaptive gradient algorithms, classifiers have been developed, and their respective accuracy has been noted. So then what we want to do is like around 10% of the records have been removed from the training. So we didn't want to lose it, because as we have only 863 samples in hand. So what we did, we have replaced the outliers with median. And then we generated models, and we noted down the accuracy. So finally, after replacing the median, we have applied Lasso regression and extracted the features, and then apply the machine learning model and noted the features. And finally, we compared which models have done a better, which model is efficient, and we validated the hypothesis accordingly. Next, result in discussion, the raw data, even without removing the outliers, we have applied all these models. The PMP is a proposed multi-layer perceptron model, what we have developed, which gives the highest accuracy than other 4 models on the raw data set. Then we have applied the outliers, we removed the outliers which are detected by interquartile range method, which gives a PMP of 76%, and the decision tree and the naive bias have given an accuracy in the next highest accuracy of 65 in that data set. Next data set we have collected by removing the outliers from one class SVM, and we found the proposed model has gained an accuracy of 78, whereas the decision tree and logistic regression gave around 68. Similarly, we have done for isolation forest. There was a mild increase in accuracy by the proposed model. It was 79. And then we have replaced all the detected outliers being replaced by median, out of which interquartile range method, the data set has given a highest accuracy of 84 than other replacement, which is done for the support, one class support vector machine and the isolation forest. Then finally, we applied on this IQ detector replace median data set, we have applied a feature selection method which gives an highest accuracy of 92%. Consistently, we see, or like we can see, there is the accuracy of proposed model gradually increases when the pre-processing in every pre-processing phase. Finally, we have selected the features smoking, pan, sada, thuibu, raw food, saum, salt intake, water source, drinking water, and sanitation are the key factors which are the cause of H. pylori, Helicobacter pylori associated gastritis. We can from this we can see the model multi-layer perceptron from the starting of the raw data 74, it increased to 92, and then from other models were also having a gradual increase, but multi-layer perceptron model has done well. This is the architecture which we have used for the proposed model. We had 17 input neurons, hidden layer. There are 4 set of hidden layers. First one with 32 neurons, second one was 24 neurons, 16 neurons, and 8 neurons. We have applied all has activation function of ReLU, and with 2 output, positive and negative. So the features, what it has extracted, smoking, saum, and salt intake has been associated with H. pylori associated gastritis in the already studied literature. And also here they have a food conservation technique.
Excuse me, can you please conclude fast? It has already been 10 minutes.
Yeah. Okay. Fine. Finally, the similar kind of risk activation accuracy has been done on PIMA India dataset, which has given gained an accuracy of 92%. And the key important of the thing of this paper is one is outliers were removed using 3 famous algorithms, and then outliers were replaced by median values and applied feature selection to get the desired result. So proposed model has given a good performance of 92% from the basic raw data of 72%. These are the references. Thank you.
Any questions from session chairs?
What are the future scope of this particular topic?
Ma'am, actually, here the gastric cancer is very high. So before we get the before a patient gets gastric cancer, they will be infected with this gastric H. pylori gastritis. So when we can extract these features and when we can bring this to public, if they can avoid this, even this kind of a disease also can be decreased, and the gastric cancer incidence also will be decreased, ma'am. So this is the main idea, because this is a collaboration work with Civil Hospital and the Cancer Research Center from Zamabuk, Mizoram.
Any other questions?
Okay, I have one quick question. So in your studies, okay, there are 5 data sets. And can you tell us, what is the proportion of the outliers that are removed or replaced, okay, in each data set approximately? Thank you.
The outliers removed from isolation forest and 1 class SPM, 10% were detected as removed as outliers. So when we take 10% from the training set, the number is like, even then that number is high. So we didn't want to remove it. So we have replaced that 10% with the median value. And for interquartile range, it's around 7%.
Okay, thank you. Thank you.
Okay, next presentation will be paper ID 188, yes. Mr. Sams Afia Banu.
Visible? Is my screen visible?
Yes, it is visible.
Good afternoon, everyone. I'm Sam Safia Banu from Tyagarajar College of Engineering, Madurai. I'm here to present my paper on behalf of my fellow members. The title of my paper is Smart Variance for Data Balancing in Intrusion Detection System using Machine Learning. So these are our table of contents. So let me proceed. So at first, the introduction of viruses and malware is one of the most notable types of attacks that can lead to serious consequences. Such types of attacks can cause irreparable damage to the infrastructure. This prompts to research efficient ways to safeguard control systems digitally from attacks that are emerging. As a result, it has become necessary to improve control system security. In order to safeguard control systems digitally from attacks, intrusion detection systems are invented. Class imbalance in multi-class classification is a major issue, as large classes tend to overwhelm standard classifiers and small ones are ignored. So this class imbalance is handled by sampling-based approach. Here, we are comparing the smart variants to find the best out of them. In this paper, accuracy is not helpful as the model predicts the value of the majority classes for all predictions. So here different evaluation metrics are used to identify which resampling method gives better performance. These are our literature survey. The first title of the paper is Applying Separately Cost-Sensitive Learning and Fisher's Discriminant Analysis to Address the Class Imbalance Problem. The drawback of this paper is this FDA proves to be less efficient. The second title of the paper is Hybrid Machine Learning for Network Anomaly Intrusion Detection. The drawback of this paper is it results in high average false alarm rate. And then the next title of the paper is Future Reduction and Classification Techniques for Intrusion Detection System. This drawback is there is ignorance of class imbalance, which has a direct impact on accuracy. The next title of paper is a Distributed Denial of Service Attack Detection using Naive Bayes and KNN for Network Forensics. The drawback of this paper is here they're using binary classifier for DDoS attack detection. And the final title of the paper is Improving the Performance of Machine Learning Based Network Intrusion Detection Systems. The drawback of this paper is this paper achieves high false positive rate and low TPR compared to other classes. Our problem description is to address the adverse effects of an imbalanced classification in network IDs using machine learning. And to we are identifying best resampling approach among the smart variants to deal with the effect of imbalanced classification, and to evaluate the data balancing techniques with suitable metrics such as precision recall, false positive rate, false negative rate, and false alarm rate, rather than concentrating on accuracy. So to meet the objective, following methodologies are used. So let me explain these methodologies. First, we chose SCADA gas pipeline dataset. Supervisory control and data acquisition systems keep track of critical infrastructure. The gas pipeline SCADA dataset, it is used as it provides a huge number of normal and attack samples. Here, as there are 8 types of attacks, class imbalance for multi-class classification is handled. And this dataset, it comprises of 2 lakh plus instances with 20 columns. So after we chose the dataset, it has to be pre-processed. So this data is pre-processed to make it suitable for machine learning model. Raw input is transformed into proper and understandable format in this step by handling missing values. A label encoding is done for converting the labels into numeric form. In our paper, instead of processing the entire dataset, a subset of the dataset has been considered for evaluation. For this purpose, stratified k-fold has been adopted. This stratified k-fold splits the dataset such that the class ratio is maintained. So after pre-processing, standardization has to be done. So to rescale the futures, a standard scalar method is used. After standardization, future extraction is carried out. Reduction of number of futures and retaining the maximum information is known as dimensionality reduction or future extraction. Here, principal component analysis is used, which is one of the dimensionality reduction techniques. The majority class dominates the minority class in imbalanced data problems. Thus, the performance is not reliable as the majority classes are inclined by the classifiers. The data which are imbalanced are dealt by various strategies. The efficient method to solve the data that are imbalanced is sampling-based approach. So here, this approach is categorized as undersampling, oversampling, and hybrid sampling. We are comparing SMOT, SMOT SVM, SMOT TNN, and SMOT TOMIC in this paper. Logistic regression is used as a machine learning classifier to evaluate various resampling methods and to find best out of them. These are our results and discussion. As I told about in pre-processing, label encoding is carried out. From this table, multi-class classification is performed by encoding all 7 types of attack classes as 1 to 7 and normal class as 0. And this is the result of class distribution. That is, as I told earlier, instead of processing the entire data set, a subset of data set has been considered for evaluation. It is observed from this table that it produces a subset of data set with the same class distribution of the original data set. This is the result of principal component analysis. From this, it is observed that from PCA, the first 10 principal components depicts 96 to 97% of the information. Thus, the significant linear combinations of features have been extracted, and the number of features is reduced from 17 to 10 using PCA. This is the result of performance evaluation without data balancing techniques. While evaluating without data balancing techniques, all attack class instances from 1 to 7 have been wrongly classified as normal class, and all normal class instances have been perfectly classified as normal, which leads to increased accuracy of 78%. And from this table, with respect to class 0, since all instances have been correctly predicted, the logistic regression achieves high precision recall and F1 score. Whereas with respect to 1 to 7 classes, due to heavy class imbalance, it leads to 0 precision recall and F1 score. So from this table, it clearly depicts accuracy is not a right metric while evaluating a highly imbalanced data set. Normally, FPR and FNR must be nearly equal to 0. FPR and FAR must be less than 0.5. So here, without data balancing technique, FPR, FNR, and FAR are not in their respective range because all instances of classes 1 to 7 are falsely predicted as class 0. So this leads to an increased range in FPR of class 0 and FNR of class 1 to 7. Therefore, data balancing techniques are needed. So as I told, we are using the SMOT variants for evaluating best out of them. The SMOT is a synthetic minority oversampling technique. SSVM is SMOT support vector machine. S-TOMIC is SMOT TOMIC. SENN is SMOT edited nearest neighbor. And these are our graph while without data balancing technique and after applying specific variants. So at first, in without data balancing approach, the classes are imbalanced as, for example, as out of 60 plus records, 70%, 78 or 70 plus percentage of.
Can you please conclude fast?
Okay. Here we are comparing the SMOT variants. And then it is observed that logistic regression with SMOT SVM has accuracy of 59% and it outperforms the other resampling methods with highest accuracy precision recall. And from this table, SMOT and SMOT TOMIC, it results in higher value of FNR. SMOT TNN, it results in higher value of FNR and FAR. So we are concluding that SSVM is the best approach. And then the conclusion is the best resampling technique among the various data handling methods is that is imbalanced, such as SMOT SVM, SMOT TOMIC, and SMOT TNS shown in this study. And SMOT SVM outperforms the other SMOT variants. The drawback observed is running time of the machine model. So this can be resolved by using cloud computing resources, which will be our future work. In case of adopting DL models as future work, it will further reduce the hindrance. And these are our references. Thank you. Any questions?
Any questions from session chairs?
No, thank you.
Thank you. Thank you.
Okay, next presentation will be paper ID 408, Mr. Alexander Nichev.
Good day for everyone. Is everything visible? Is everything
Yes,
okay?
it is visible. You can turn on a slideshow.
Okay, great. My name is
Yes.
Alexander Nichev, and I want to present our work entitled Choosing Splitting Strategy for Evaluation of Latent Factor Models. Let's describe the problem we've tried to solve.
Alexander, can you
Yes.
on your video, please?
On my video?
Yeah, please. If
Yes,
possible.
okay.
Yeah.
Yes.
Thank you.
Great. Let's describe the problem we've tried to solve. Recommender system solves the task of users' interest prediction. Often, this task is stated as a racing prediction task. In this case, matrix factorization algorithms show state-of-the-art performance on many datasets. To train, validate, and optimize such a model, it's needed to split a dataset into several parts. There is no problem. Data splits distort the original distribution of points, so a model can learn an inappropriate patterns or be poorly evaluated. There are several investigations devoted on this problem for machine learning models in common, but there are no known results for latent factor models. According to the literature review, there are 4 common splitting techniques used for recommender systems. They are well known, but let's check how are they examined for now. The most simple and common solution is the usage of random splits. This process is simple and fast, but depending on the random split, the data distribution may be heavily distorted. This is particularly important for recommender systems because they should leverage existing biases to make accurate predictions. There are 2 generic solutions to this problem. The first one is k-fold cross-validation. This is a well-known technique. It smoothens new biases and make evaluations more accurate. However, it drastically increases training times and not always gives needed results. The second common solution is the usage of distribution preserving methods. They solve the problem in some domains, but they are hardly applicable to recommender systems because of the nature of its datasets. They always contain some IDs and so on. A specific solution for recommender systems is the usage of temporal splits. This assumes records to be sorted by transaction time, and the earliest transactions goes to train sets, while the latest ones are sampled to validation and test sets. This method has been examined for neural recommender models, but not for matrix factorization ones. So here is the summary. There are a couple of acceptable methods, but there is a real need to evaluate them for matrix factorization models. So the goal of our research is to experimentally estimate how much the choice of the data splitting strategy impacts the performance and evaluation times of latent factor models, and try to determine what strategies should be used in different cases. How do we reach this goal? We use 15 datasets from different domains. Most of these datasets are common in recommender system area and contain up to 10 million records. There are evidence that different splitting strategies may change their behavior depending on the dataset size or its state and time. So we create 5 versions of each dataset to check if behavior will change. Each version is made by cutting lightest records from a dataset, and the largest version is the original dataset. We use SVD and the SVD++ algorithms to make matrix factorization models. These algorithms are simple enough to perform hundreds of experiments, but also they allow making some conclusions about matrix factorization algorithms in common. Experiments are performed in the following way. A dataset is split into train, validation, and test parts. To make the test part, we always use the same strategy, and to make training validation ones, we use different strategies. Next, a model is fit and validated. We use two metrics, RMSE and NDCG at 10. Hyperparameters are optimized using Bayesian optimization, and next we get final estimations on the test part. According to the literature review, we examine 4 splitting strategies: random splits, k-fold cross-validation with random splits, temporal strategy, and temporal strategy with stratification on users. To analyze experimental results, we state 4 research questions. The first ones are about the numerical comparison of metric values and evaluation times. To answer them, we normalize given values and visualize them at violent plots. Since examined datasets have different characteristics, we group them by domain. The third question is, do metric values depend on what splitting strategy is used? This question is about statistical comparison. In our case, cross-call wireless test is suitable. It is also important that to provide a sufficient number of points, so we enlarge dataset groups. And the last question is about strategies behavior and time. We count how many times a strategy has been chosen as the best one per each dataset version. The null hypothesis is that there is no dependence between the dataset version and the optimal strategy choice. In this case, chi-square test is applicable. So experiments are performed using our own fast implementations of SVD and the SVD++ algorithms and well-known Python libraries. Source code and raw experimental data are available on GitHub. Here are the while and plots for the first 2 research questions. Different colors represent different splitting strategies. RMSE and the NDCG plots show that there is no visible difference between metric values given for different strategies. There are some minor differences in distributions medians in favor of temporal strategies, but numerically the difference is around 0.001. Practically, this difference doesn't make you. The results about evaluation times obviously show that the usage of cross-validations, see the orange violin, increases needed time from 3 to 6 times. Other strategies require pretty the same time, but there are small evidences that temporal strategies lead to the lowest times more often than others. This can be explained by the peculiarities of algorithm implementations. So let's check these assumptions statistically. This table shows p-values given for cross-call wireless test for the hypothesis that there is no dependence between metric values and which splitting strategy is used. Almost all p-values are 10 to 1, so the null hypothesis is accepted in all cases. What about chi-square test for the dependency between dataset version and the optimal strategy choice? According to the grouping, we've got 48 p-values. Only 4 of them are lower than 0.1, while other ones are also too high to reject the null hypothesis. This could be treated as a minor evidence in favor of temporal strategies for larger datasets, but the difference in metric values are still practically too small. So for all 4 research questions, we've got the answer that there is almost no practical difference which splitting strategy is used for our data. Also, there is no need for cross-validation in this case. These results cannot be explained by the fact that models are just poorly fit, because given metric values are actually good and confirm the results from other papers. So let's summarize what we made. 1,200 experiments are performed. Both numerical and statistical comparisons show that there is no difference with which splitting strategy is applied to train and validate latent factor models. There is no need for cross-validation, while temporal strategies may slightly decrease training times and also theoretically make evaluations more honest because of the transaction leakage problem or when a model learns records from the future. So as a conclusion, for matrix factorization models, we recommend leveraging only business-specific logic to choose a data splitting method. In common case, we recommend using temporal strategies if they fit your case. So there are three most important references, but please check the full paper to find the full list of cited works, especially by the authors of data sets we've used. Thank you. Feel free to ask any questions.
In the last point, you were saying that temporal user approach should be used. That would be more useful. Could you please elaborate a bit more on that line?
Yes, of course. There are at first there are small minor instances that the usage of temporal strategies lead to slightly lower times. So here we see that the most dense distribution around 1 is for temporal strategies. The second and very important problem is that they lead to avoiding transaction leakage problem. For example, when we use random split, we can train a model on the record from the future and test it on the records from the past. So it's not very correct, but when we use temporal strategies, this problem is always avoided. So it make evaluation more honest. And metric values will be just at least as good as for other strategies.
Yes, I am able to understand it. Thank you.
Thank you.
Yeah, I have one quick question. Okay, in the middle part, you mentioned about the ANOVA, but it seems I can't find it in the results. So can you elaborate a bit more about this analysis?
Sorry, I missed. What did I mention in the middle part?
About the ANOVA. Yeah, somewhere in between. Okay, I find it. Yeah, ANOVA, but is there a result in the last part? Yeah, the next slide you mentioned about the ANOVA.
ANOVA.
Yeah, somewhere in the Q3, the question 3, research question 3.
Research question 3. Yes. Okay. So, sorry. Got you. We use ANOVA is distribution.
Oh, yeah. Okay. Yeah. Understand. Okay. Yeah. So I see that you use another test to substitute the ANOVA, right?
Yes.
Oh, okay. Yeah. Thank you.
In distribution normal. Thank you.
Okay. Yeah. Thank you.
Okay. Any other questions? Okay, we will move on to the next presentation. Just paper ID 473, Mr. M. Ramesh.
Hello. Is it audible?
Yes.
Hello?
Yes, it is audible.
Yeah.
You can present your
screen. Yeah. Okay. Hi all. Good afternoon. This is Ramesh from NIT Goa, research scholar. So today I am discuss about light detection with a smoke technique and supervised machine learning algorithms. So today these are table of contents, introduction and methodology and smoke, experiment and analysis and conclusion, future. So this is a background. This is a background. Here we are using the ECG data. See, ECG data is a gathered for light detection. Is a guilty and innocent. ECG data we gathering data from using the consoled information test. In this consoled information test, we are using the three stimuli. One is target and probe and
Excuse
irrelevant.
me. Excuse
Yeah.
me, Ramesh. Can you please turn on your camera,
Yeah.
if possible?
Yeah, sure.
Thank you. Thank you.
Yeah, madam. Okay. So here 16 channel data we are using ECG data. So ECG data we gathering from console information test. These console information test we based on the three stimuli, target and probe and irrelevant. We stimuli we have to gather the ECG data. So here ECG data having the imbalanced data set. So in this imbalanced data set, if we are using the applying the machine learning algorithms, so we will go for very less system performance, and as well as we detecting the light detection is going to poor. So in this research we have to apply this mode technique. So literature survey here earlier they are used to three channels data set. In this channel data set they are applying the machine learning algorithms. So they are showing the system performance. So here in this our research we are using the 16 channel data set. So here 16 channel data set having the imbalanced data set. So here we are using this mode method, improving the imbalance ECG data set, as well as we have to applying the different classifier KNN and DT and LR, random forest and SVM. For applying the improving the system, and detection, light detection. So here SMOT is a synthetic minority oversampling technique. SMOT is helping for improving the minority class. Here we having the major class and minor class. So if you have,
excuse me, Mr. Ramesh, can you turn on your video? Your video is not coming.
Okay. So here a SMOT technique is improving the minority classes. So see here we are using the Euclidean distance distance. We are using the find out to the improving the minority class to the equal to a majority class. So, here methodology. So here we ECG data we gathering the data from console information set. Here we have using the two labels. One is a guilty label and innocent label. So ECG data having total 5,930 records. Here 585 test records and 5,345 the trained records. So here this methodology here ECG data. So we are applying this mode technique. Here applying this mode technique. A major class and minor class means here guilty class having the innocent class. So innocent class having the less number of records. So we based on this mode technique we are improving to the innocent class. After then we have 16 channels. Then we apply the 16 channel selections. Then we have to divide it 90% and 10% train data and test data. So then we can apply the supervised machine learning algorithms. Based on this we can detect in light detection, and we divided guilty and innocent. So these are result sections. We have to show this mode and without SMOT. If you are applying SMOT techniques, we will get good performance on the SVM class, where we got 95.6 and 98.64% accuracy. And without SMOT, we can apply the very less compare with SMOT. conclusion means here is more technique we can apply the improving the innocent class compare with guilty class. So we are equal to innocent and guilty class label data. Then we can apply in the machine learning methods. So then we can predict the lie detection as well as improve the system performance. Here SVM getting the more accuracy 98.6 percentage. So references, these are it. Thank you. Hello.
Any questions from session chairs? Any questions?
No
Kindly
offense.
go to the conclusion slide.
Mr. Ramesh, can you please present your slides?
Yes. Yes, madam.
So when you have the highest accuracy of 95.64 percentage, and have you in any of the slides tried to calculate the relative accuracy, how much accuracy increase has been there with respect to state of art on this particular data set?
Madam, I mean you.
So is there any, here you have compared with different classifiers. I want to ask,
Madam.
The state of art means there would be in the latest reviews, there would have been a particular classifier which would have been said that this is the latest state of art. Have you done any percentage calculation that yes, from with respect to state of art,
Okay,
this present classifier is giving 6% increase in accuracy or something of that sort?
Oh, a comparison with previous existing or present,
Yes.
madam?
Yes.
Yeah, actually, I didn't mention because I have a previous existing comparison. The previous they are showing 92%. Then I have to improve the 95.64, madam, because.
Okay, so you haven't shown it here, but you have done that, right?
Yeah, I have done, madam, but because I don't have data right away.
Okay, fine.
Yeah,
sir.
okay,
Fine.
thank you. Yeah.
Thank you.
Okay, that was the last presentation of the session. On behalf of NIT Raipur and the organizing committee of the conference, I thank you all for sparing valuable time as well as providing valuable insight to the others. All the session chairs are kindly requested to fill the evaluation sheet so that the best paper award can be decided and finalized. The Google Form links for these evaluation sheets have already been emailed to the respective session chairs today morning. Thank you all. Thank you very much.
Suren?
Yes, sir.
Did you ask for group photo?
Yes, sir. Starting we have taken at the start of.
Okay. Thank you. Thank you, Dr.
Thank you all.
Manflo.
Yes.
Yeah,
Welcome.
Thank you for your invitation.
Yeah. So
Thank you so
may
much.
I also Ganpriya ma'am?
Yes, sir.
Yeah, can
Yes,
you
sir.
switch on your video?
Okay, just a few minutes.
Kaushik Malik, Dr. Kaushik.
Yes.
Thank you. Okay. So I would like to request you at 4 o'clock keynote talk of Professor Hugh Wang from Queen's University of Belfast, UK, is scheduled. So you and your scholars, if possible, please ask them to attend the keynote talk, as well as also all you are invited to attend the validatory function, where we will also announce the base papers. Okay. Thank you. Thank you, Sonal ma'am.
Thank you, sir. Thank you all. Thank you.
Thank you all.